Example 1, the distance required for an automobile to stop is directly proportional to the square of its velocity. So just a few lessons ago we did direct and inverse variation. Another way of doing this or describing this is called proportional. So it's directly proportional to or inversely proportional to. That means direct variation, inverse variation. So the distance varies directly as the square of its velocity. Right now, the other difference here, other than the words directly proportional instead of varies directly, is notice it says the square of its velocity. Okay, and a lot of people get messed up on square and square root. So the square of its velocity looks like this. The square root would look like this. And they could do either one. In this case, they said square, so we're going to use this one here. So distance varies directly as the velocity squared. So we're going to set it up just like we did before, but instead of just having d equals k times v, now it's d equals k times v squared because it says velocity is squared. Once you get that sentence, or once you get this equation written, the next sentence is going to give us some information. If a car can stop in 200 meters in 20, I should say at 20 kilometers per hour. At 20 kilometers per hour. Okay, so they're giving us a specific distance and speed of the car. So I know that 200 meters is the distance when the velocity is 20. But what am I supposed to do to the velocity? Squared. So 20 squared is 400. So again, v squared means whatever the velocity is, we have to take the second power. If you can do that mentally, fine. If not, write 20 squared and then maybe use a calculator to evaluate it, verify you get the right number. All right, 200 equals k times 400. Now here's another thing algebra students do. Hopefully, I don't want to call you beginning algebra students anymore because we're like right here towards the end of the course. But some of the mistakes people make, 400 divided by 200 is 2, and 2 is a nice friendly number, right? People see 200, 400, they just put k equals 2 without thinking. All right, be careful. K is being multiplied by 400. The rule of algebra says we divide by what's being multiplied by the variable to get the answer. And when we look at a fraction, when the top number is smaller than the bottom number, we're going to get a fraction structure. So 1/2 is what k equals. So be careful that you do that properly there. So I end up with d is equal to 1/2 v squared. So just like before, once we know what k equals, that's the constant of variation. It's going to be put into our original structure, changing k into that number. And then we read the rest of the problem to see what they've given us and what they're asking us for. The rest of the problem says, what will be the required stopping distance? So we're looking for d, right? At 28 kilometers per hour. So now, d is going to equal 1/2 times 28 squared. 28 squared is not quite so easy to do in our head, right? So that's the point where I'm going to get my calculator out, type in 28 squared equals 784. Alright, so 28 squared is 784. D is what we're looking for. Half of 784 is 392. What kind of unit do you think should go on that?
Kilometers.
You think kilometers? Anybody think anything different than kilometers?
Meters.
And why do you think meters, Kim?
Because it can stop in more than
Oh, yeah.
Yeah. The original distance unit was meters, so the final distance unit is going to be meters also. So these problems work in whatever unit you're going to use in the problem, but you got to stay consistent. So this was meters, this was kilometers per hour, this was kilometers per hour, so we should get meters out. So make sure that happens. They're not going to do anything tricky right now, but just make sure you get the proper units on your answers. That's how you establish the proper units.